Another common type of distribution would be the binomial distribution. Here, I want to let you know what we mean by dummy variables. Dummy variables are essentially variables that only take on two values, or variables that have only two categories to represent the absence or present of a characteristics or attribute. Dummy variables take on the binomial distribution. Binomial distribution only takes two values, whether an attribute, a characteristics, or an experience is present or absent in a person. It is very similar to flipping a coin. When we flip a coin, we can assign the number 1 if we get a head, and we can assign the number 0 if we get a tail, or we can do it the other way around. We can assign a number 0 to heads and a number 1 to tail. If you Google the word dummy, you will find that it also means stand-in, or something that is used as a substitute. In statistical sense, dummy is a number that is being used to represent or to substitute for a qualitative characteristics. For instance, we all know that there are two sexes. You can either be males or females. Thus, we can arbitrarily assign a number for each sex category. We can assign the number 1 for males and the number 0 for females. We can also do it the other way around. We can assign the number 0 for males and the number 1 for females. We can also group students into two categories: those that experience bullying and those that have not experienced bullying. We can assign the number 1 to students that experience bullying and the number 0 to students that have not experienced bullying. The binomial distribution can eventually approximate a normal distribution, especially when the sample size gets larger. Let's say I have 40 students in my class, and let's have each student toss a coin 10 times, and we count the number of heads they got. We assign the number 1 to the heads and the number 0 to the tails. We then draw a line on the blackboard with numbers below to represent the number of heads each student got. We have the students each report how many heads out of the 10 flips they had. We record each of them out. You will notice that most students report having 4 to 6 heads out of 10 tosses. The diagram on the left approximates a normal or bell curve as the sample size gets larger. This is another example of how a binomial distribution can eventually approximate a normal distribution. Let's say we record the demand for a specific brand of ice cream at a particular store on a given day. Here, Y represents the number of times that the brand of ice cream is demanded on a given day. Py is the probability associated with the number of demands for a given day. As you can see, the probability for demanding that specific type of ice cream peaks between 1 to 4 times a day.